Yeah, I'm in Madrid. I'm going to go to travel from Madrid to Alcalá in one of the marvelous intercity trains in Madrid. And today we are going to talk about relativity. So it's going to be a complicated episode. So put your thinking hat on, and welcome to your cosmic kingdom. Today we are talking about time, and exactly will it take the same time for me to get to Alcalá that for my friend Susana who is waiting for me there, and exactly what my wristwatch will show when I arrive in Alcalá, and what my friend Susana's wristwatch will. This train departed approximately at 9:10 from Madrid to Martin. It is expected to arrive in Alcalá around 10 sharp actually. Concept in mind that the time is something that is immutable and it's absolute, meaning that the time for me in this train, it is the same time as for my friend Susana in the station, but that is not true, and it took us 2,500 years of science to realize that that is not true. Time is not an absolute thing, and because I'm traveling at a relative speed to the station in Alcalá, for me time is slower. I know it's totally counterintuitive, it's mind-blowing. What is happening here is we assume time that it's absolute thing, it's something that it's the same in this train or on the ground, and it's not. This was discovered by Einstein in the early 20th century. The important thing is the relative speed. So now we are almost stopping at the station in Coslada, and at this time my wristwatch and the wristwatch of someone there will just beat at the same time. My heart will beat at the same time as him. But in the moment we start moving, at that moment my reference frame substantially changes from his. That in that instance, our time, our internal watch, the time in general changes. What it happens in real life is that this difference in time is just tiny, really small. It is just one part in, I don't know, trillions in a second or something like that. So we don't realize that the time is not absolute. Even here, for example, what is interesting, it's not also about the absolute speed, because there is not such a thing as absolute speed. So I can measure the speed now to the ground, but also I can measure the speed to that train that is traveling there, and there is differences in our speed, and that difference is which cause the differences in our time frame, and that is what is like impossible to believe. The first time this was proven was observing the decay of cosmic rays. Cosmic rays are formed by atomic particles, and they just hit the atmosphere and they decay in different other particles, and you can measure the decaying times of these particles in laboratories. And what they found is that the decaying times of these cosmic particles were higher and consistent with general relativity. And today, we all use something that needs to correct with that, which is GPS. GPS has a series of satellites orbiting the Earth, and they have like a very precise atomic clocks inside, and they need to account for the difference in relative velocity with them. Well, I think I'm arriving now. Here I am with my friend Susana. I finally made it. As you can see, it's 10 sharp, and in our wristwatch, it's the same time, but it's because they don't have enough precision to measure relativity. See you guys next week. Bye-bye. This is Alcalá. Behind me is the house where Cervantes was born, and you can see that I have Don Quixote and Sancho sitting on a bench welcoming us to this marvelous medieval city.